Hello everyone, welcome to Mining Now, a product promo with one of my favorite companies. Said it many times, I'll say it 100 more times till Luke stops taking my call. SafeGauge. I love what you do. Loved it from the first time we had you on the show. And today we've got Dan Hawkins, industrial designer at SafeGauge.
Yeah, great to be on the show.
You're actually part of the design team of these products?
Yeah.
Wow.
Yeah, that's right.
That's amazing. Well, so I'm directly complimenting you when I always talk about the design. So
thank
you.
Well, complimenting the team.
Well, something I've learned. I saw the tag somewhere. Oh, it's right here, back here.
Yeah.
There's this little triangle. So then I learned, of course, if you want like actual Australian-made Uggs, you look for that little triangle.
Yeah.
So now that I've seen that many times, but it just was a thing I saw.
Yeah.
This means it's designed in Australia.
Yeah.
And made here, right?
Yeah. So we go through an application process, and basically you log where all of your components come from, where the final assembly happens, which for us is in the same office that I work in, that the engineering team works in Beresfield in Newcastle. So they're all assembled there, calibrated, tested, and then shipped out from there to all over the world now. Yeah, which is really cool.
What sort of separates out that high-level testing from the company that wants to use all the feature? I'm guessing if you've got a large fleet company, they need to collect all that data. If you're working at like a mechanic shop, maybe they just need to test it, know what's happening with the machine. Is that sort of
fair
example?
Spot on. Yeah, so your smaller contractors or mechanic workshops, they just want to basically have a way, even just where they can do the test with one person as opposed to 3 or 2 people, where one person can put on a couple of sensors and be up in the cab operating the machine, getting those live readings.
Yeah.
So that's a good scenario. But then on the other end, where you'd be using that reporting, data logging, and then basically sending that to your supervisor, that we find that the large companies, for example, Hastings Deering, one of their use cases is doing a test and actually having the proof there in a PDF report showing that, hey, we're getting 1.3 millimeters movement in this bush that's only meant to have 0.8 millimeters.
Right.
And they've had scenarios where they've told the customer that in the past, and they've said, don't really know if I believe you, like it's probably going to be fine, don't replace it.
Right.
It might have gone and failed in the field. But they can say, hey, we've got this evidence, this PDF report to show this is exactly the reading we're getting, and the customers are a lot happier to go, okay, well, I can see the proof there, can see why you did it, all makes sense.
It's so funny why doing these shows is so interesting, because you think you know a product, and I've never, in the conversations with SafeGauge, and I've interviewed a few different people from your team, it's never been from that angle, is if you're telling the client something, and they go, oh, it's fine. Obviously, if you're in-house, you're testing your gear going out, all that makes sense, but I never thought of someone just saying, yeah, it's fine. It's like, no, it really, like, we actually have that information now. This is not a theory. This is not from us eyeballing it. This is not from us wanting to give you an extra service. This is actually a reading. What about the customer feedback? How does that sort of play? Where does this sort of the first entry point for customer feedback come into? Would it land on your desk first? Where does it go?
So in the product specialist role, it would sort of come straight to me, and now we've got someone, Hash from the engineering team. He is sort of taking all the new ideas and scoping out, visiting customers to get those insights. But the customers they've guided the roadmap of products. So for example, the push rod there's a particular.
That's this right here?
Yeah, that's the one. Okay. So you can see it's got 2 little magnetic mounts on either side, and then the measurement that they're getting is the movement between those two points.
Right, okay.
So there's a particular test called the steering shake test that they do on a dump truck, and what that does is it actually tests for the wear in all the 8 steering linkages. So, when you turn right, all the linkages move, and then twist the wheels around to turn the way you want to go. All those need to be operating, to spec. Otherwise, if they fail in the field, it can cost in the hundreds of thousands of dollars to get the truck back in, repair it. The amount of time that goes into that is yeah,
And never mind downtime, and
extraordinary.
all that. Yeah.
Exactly. So the way that they could do it in the past was with a dial indicator. I guess the customer feedback on that is that, hey, this particular material that these linkages are made of is a cast steel, which doesn't quite have the same magnetic properties as something that's like machined, like a cylinder. And so these magnets don't have quite as strong a holding strength. And when you've got this weight that's at a pendulum further out, there's the risk of that actually falling off when they shake the machine vigorously.
Mm-hmm.
So,
which is what is required for the test.
That's the shake test, right?
Yeah.
And so what we did is we went, all right, what's a different way of measuring it? You can feel that in your hand. It's fairly lightweight. So there's not a whole lot of weight.
So it's distributing out the... So this is still magnetic then?
Still magnetic.
Okay.
And then you've also got these V-blocks here, which this was more customer feedback from when we designed the first prototype of this. We went, all right, so there's a use case here. We'll try this sensor to measure the movement. And then we had flat magnets, and we went out to site, and they needed to mount it to a curved surface.
Right.
So if you've got a flat magnet on a curved surface, it's going to like wobble around.
Right.
So we went, all right, let's do a V-block. And so one of our engineers, Josh, who was leading the project, designed this V-block. And when that's on a curved surface, it's nice and solid. And then you can mount that directly on top.
There. Yeah.
And you've got a really solid location to basically take your measurement from. And that's really important for the accuracy of that actual measurement.
Again, it's very SafeGauge. It's just like it's designed in exactly the way you think it should be designed. There's no like, you didn't do some sort of weird slide thing, or there's nothing weird going on. It's just like, no, this is just built how it's supposed to be built. It's done. So this now, like, how often, if you're testing with this, how often would this attachment go on here?
Every time.
Every time.
So and it'll go on one end. So it depends where that particular sensor is located.
Right.
So because they can use this push rod for a range of tests, so it's not just for that steering test.
I see. Okay.
But yeah, then they pretty much use these all the time for the steering test because they're actually on a steer cylinder, which is curved, and going to a ball joint, which has a curved face.
Right.
On the other side as well.
And so as you're doing the shake test, this is just basically sliding in and out.
Yeah, it's just going in and out. And it's really cool to see, actually, because there's 8 linkages, and they're getting 8 measurements at the same time.
So you put 8 units on? I see. Yeah. And then, so these 8 units, then they would connect to this, which is your, what's it called? The
MultiTool Pro.
MultiTool Pro.
Yeah.
And now you're reading all that in there.
So it's really cool, actually, to see it populate, because on the next screen, if this was the test, you'd have those first 8 lines.
Yeah.
And it's got a function in there where it calculates the total movement. And so that just turns on automatically. Set up all your sensors, start your test, zero them all, and they're doing the shake, and these numbers are basically just forming on the screen of up to the point where they get the maximum movement.
Yeah.
So then on the screen you'll have, 1.2, 0.9, 0.8, 0.8, 0.7, 2.4. You go, okay, that one needs to be replaced.
Wow.
So that can take, what used to take 2 hours with 3 people, you've got an operator, a spotter, and someone under the machine, with a hand touching the steering linkage, potentially, at risk of being crushed by all the moving parts under there.
Yeah.
You can now do it with one person in 15 minutes.
Yeah.
Just bit of setup, do the shake test, all your readings, export the report, and then identify which ones might need to be replaced. And
I just want to do a quick pivot before we wrap up onto the data side, because that's, I don't know how many episodes we do about data now. What is actually happening? Where does that go to? Where is the workflow? You already sort of touched on it with like a big dealership. That's obviously going to be an important factor to them. But how much of that has been in the conversation when you're talking to new clients?
Yeah, so I think from where we were with just the sensors, just displaying on a basic screen that just showed them the live readings, a lot of the customers were saying, can we get this in some other form that we can then, show to the supervisors or show to the client? And that was where we went to the tablet and went, all right, we can do more sensors on here. And now we've got a software team of a couple of guys who are, able to code some really cool stuff into this tablet. But I guess the value is to be able to have the reporting, have those readings accurately on the tablet. But on the report side of things, what we end up with is a really simple report outlining the machine details, the test that's been done, and what the actual readings were. And so that, I guess, gives a nice simple view of what has been done, how much movement there might be in a particular component, or how far astray the pressures are running on a hydraulic system. And yeah, there's a bit of analysis in there as well. So rather than having to watch the live readings the whole time, technicians can actually do the test, let all the sensors just do their thing, and then can go back and actually overlay a couple of sensors on top of each other, for example. So to see, all right, I just want to make
and
sure
that's all done through there, or that's done something?
That's all done.
Oh, okay. Wow.
Yeah, so I guess our data, the data we speak about is all in the tablet. It's there at the time of testing.
And then that report just gets sent out. If it needs to go beyond that, now you just send it out.
Yeah, so we're keeping that connection between the technician doing the test, analyzing the data, and creating a report. We're just keeping all of that basically in that one spot. So you're not kind of creating a disconnect between, all right, one technician did the test and then someone else is.
Well, I was going to say the technicians must love that. They must just go, yeah, that's.
Yeah.
Because it does feel sometimes like some of the stuff, it's just like, it's almost just taking the information and just putting it out to somewhere else, someone in management or something. Yeah. And it's like the technician is sort of the person. It's like it's going to go all the way out there just to come back around.
Yeah. Yeah. Because you might have some pressures that are running, and that those pressures might be showing up when the machine's cold, and then the technician knows that, so they just go, all right, forget about that. We're waiting till it warms up, and then we're going to get our actual pressure readings. So there's a lot that actually comes from those technicians because they've got the experience and the knowledge of the machines that they're working on, and basically that insight to what's happening at the time, what that data's doing, then they can put any notes in there to save for later.
What is the most complicated design you've had to do here? What is the one that you went, this is going to be tricky?
Dial indicator, 100%. This was actually my first project at SafeGauge.
Okay. So
did the mechanical housing, this coupling here, worked with an awesome industrial designer, John, who sort of contracted in. And inside of there's bushes, a pin, springs, all has to be accurate, aligned. Trying to house all the circuitry and electronics in there as well.
Amazing.
And make sure that it just runs smoothly and reliably every time. It's one of the biggest challenges, but we got plenty more coming, and it's really exciting.
Yeah, is there still a lot of design and is that team pretty busy still?
Yeah. We've expanded to a team of 7 or 8 engineers and designers.
Amazing.
And got some really cool products coming soon.
Well,
we can probably check out next time you're in Australia.
Well, there's a couple things we need to do. I got to convince the SafeGauge team to put us out on site, and we'll do an episode with the with the shake test being done in the background and stuff. But we'll take some partners to arrange all that. But I'd love to see this out in the field soon. So amazing what SafeGauge is doing, and thanks for doing the show.
No, pleasure, Jerrod. Thank you.
Thank you. And thank you, everybody, for watching. Of course, as always, there'll be links to go check out SafeGauge. Follow them on LinkedIn. Are you on LinkedIn as well?
I am. Yeah.
Okay. So we'll put our guest name. You can connect with him directly. Thank you, everybody, for watching. Thank you for all the support, and we will see you on the next episode of Mining Now.